Good morning friends, I am back again with one more video lecture on the topic variation of parameters. Now in today's lecture we will solve one interesting example based on the variation of parameters. Now example is solve by method of variation of parameters d to y over dx square plus y is equal to 1 upon 1 plus sin x. Now we will solve this problem in 3 steps. Step 1 means to find the complementary function of the given problem. Step 2 means calculate the Wronskian means w, and this is equal to y1 y2 prime minus y2 y1 prime. And third step means to find the particular integral of the given problem according to variation of parameters. Now solution. Now first we write the symbolic form of the given problem. Now d2y over dx square, so we write it as d square plus 1 times y. This is the d2y over dx square plus y is equal to 1 upon 1 plus sin x, where this d means differential operator and this is equal to d over dx. Now auxiliary equation is this, equating this d square plus 1 to 0. The d square plus 1 is equal to 0. Now solve this equation, solve this auxiliary equation, that is d square is equal to minus 1, that is d is equal to plus minus I, means d equal to imaginary roots in the form of alpha plus minus I beta. So here this alpha is equal to 0 and beta is equal to 1. And therefore, C of is equal to e to the power alpha x, but alpha equal to 0, the e to the power 0x answer is 1. C1 cos beta x, beta is 1, the C1 cos x plus C2 sin x. So this is the complementary function for the given problem. Now let this cos x be the y1. So let this y1 is equal to this cos x and y2 is equal to this sin x. Now differentiating this y1 y2 with respect to x. Now derivative of y1 denoted by y1 prime, and this is equal to derivative of cos x, answer is minus sin x. Similarly, derivative of y2 denoted by y2 prime, and this is equal to derivative of this sin x, answer is cos x. So therefore, now this Wronskian w is equal to y1 y2 prime minus y2 y1 prime. Now this is equal to, now this y1, the y1 be the cos x times y2 prime be the, again be the cos x, minus y2 be the sin x times y1 prime be the minus sin x. Now this is equal to cos x times cos x, answer is cos square x, minus minus plus sin x times sin x, answer is sin square x. Now cos square x plus sin square x, answer is 1. So here this Wronskian be the 1. Therefore, by method of variation of parameters, this pi, this particular integral, is equal to v1 y1 plus v2 y2, where v1 is equal to integration minus y2 times x upon w dx, and v2 is equal to integration y1 times x upon this w dx. Now v1 is equal to integration minus y2. Here y2 be the sin x and capital X be the 1 upon 1 plus sin x upon w, and here w be the 1 dx. So this is equal to integration minus sin x upon 1 plus sin x dx. Now integration of this minus sin x upon 1 plus sin x. So we write this minus sin x as v1 is equal to integration minus this 1 plus sin x minus 1. Yeah, this is the minus sin x upon 1 plus sin x dx. Now dividing first term of the numerator by the denominator and dividing the second term of the numerator by the denominator. So this is equal to minus 1 plus sin x upon 1 plus sin x. Answer be the minus 1 because 1 plus sin x, 1 plus sin x get cancelled and this minus sign. Now minus minus plus plus. Now this 1 upon 1 plus sin x dx. Now integration of minus 1, answer is minus x plus integration of this 1 upon 1 plus sin x. This is equal to minus x plus now integration of 1 upon 1 plus sin x. Now we write this 1 upon 1 plus sin x like this, multiplying and dividing by 1 minus sin x. So 1 minus sin x upon 1 minus sin x times 1 plus sin x dx. Now this is equal to minus x plus integration 1 minus sin x. Now 1 minus sin x times 1 plus sin x, answer is 1 minus sin square x. Now 1 minus sin square x be the cos square x. Now 1 upon cos square x, answer is sec square x minus now sin x upon cos square x. The sin x upon cos square x, so we write this as sin x upon cos x, that means tan x, and 1 upon cos x, that means sec x. So we write sin x upon cos square x as sec x times tan x. Now this is equal to minus x plus integration of sec square x. Now integration of sec square x, answer is tan x minus integration of sec x tan x, answer is sec x. So this is the V1. V2 is equal to integration y1 times x. So y1 be the cos x times capital X, means right hand side of the given problem, 1 upon 1 plus sin x upon w, w be the 1. Now this is equal to integration cos x upon 1 plus sin x. Now its integration be the simple. Derivative of this denominator be the cos x, means be the numerator. Its integration be the very simple. Log of denominator means log of 1 plus sin x. So therefore V2 is equal to log of 1 plus sin x. And therefore Pi is equal to V1 y1 plus V2 y2. Now V1 be the minus x plus tan x minus sec x times y1. Now y1 be the cos x plus V2. Now V2 be the log of 1 plus sin x times this y2. Now y2 be the sin x. So therefore Pi in particular integral is equal to minus x times cos x plus tan x times cos x, means sin x, minus sec x into cos x, the answer is minus 1, plus this sin x times log of 1 plus sin x, log of 1 plus sin x. And therefore complete solution of the given differential equation is y is equal to complementary function plus particular integral, that is y is equal to CF. Here CF be the C1 cos x plus C2 sin x plus Pi. Here Pi be the minus x cos x plus sin x minus 1 plus sin x times log of 1 plus sin x. So this is the required general solution of the given differential equation according to variation of parameter method. Hope all of you have understood this problem. Please subscribe the channel and let me know your comments and feedback. Thank you.